Okay, so looking at Unit 4, here we're going to talk about Unit 4 kind of in a nutshell. The very first thing we did in Unit 4 is we looked at ratios. What a ratio is, it's very similar to a fraction, such as, the fraction 3/4. Writing that as a ratio is actually the same thing as 3, and then that's supposed to be a colon, 3 to 4. So ratios and fractions can kind of be compared to each other in that they're very, very similar, except ratios are usually written to compare two different things rather than a part over total. Whereas if I'm looking at the fraction 3/4, I'm looking at, that I had 3 apples out of the 4 pieces of fruit in the fruit bowl. Or there are 3 girls out of the 4 people in the class. So it's a part out of something. Whereas a ratio is usually used to compare two things. So ratio here 3 to 4 would be like saying there are 3 apples to every 4 oranges in the fruit bowl instead of 3 out of 4. Or 3 girls to every 4 boys in the classroom rather than 3 out of 4. So that's the reason why we use ratios instead of fractions. But they can actually be simplified the exact same way. That being said, if I was looking at, say, number 4 on your all's take-home quiz, it says 24 to 8. So if that were the fraction 24 over 8, we would simply just, again, it's an improper fraction, so we would divide that 2 and it would give me 3. But in looking at that as a ratio, we actually reduce it like we did our proper fractions. So 24 to 8. Actually, we're going to look at both 24 and 8 and ask ourselves, can I divide both 24 and 8 by the same thing? So actually, yes, 24 and 8 can both be divided by 2, 4, or 8. You can start anywhere. Either way, we get down to 3 to 1. Because 24, if I divide them both by 8, 24 divided by 8 is 3, 8 divided by 8 is 1. Because a ratio must always stay a comparison of two numbers, so my answer, if I want to leave it as a ratio, it has to be two numbers. A second ago we said if that was the fraction 24 over 8, that would have reduced to 3. Well, you could do that, but thinking that 3 written as two numbers or written as a fraction is the same thing as 3 over 1, so therefore that's the same thing as the ratio 3 to 1. So you totally could do that. It just doesn't work for every single ratio that way, meaning like the ratio 10 to 12. If I was saying that there are 10 girls to every 12 boys in the classroom, that's actually simplified as 5 to 6 because I can divide both 10 and 12 by 2, leaving me with 5 to 6. Obviously, it doesn't work if I take 10 divided by 12. I would get some weird decimal, and that's not the right answer. The reason why we can't do that, again, because we need our ratio to be like this. I need it to be a comparison of two whole numbers. Now, that's the thing. I want it to be two whole numbers, so when we come across ones like number 1 on your quiz, you have 1/3 to 45. Now, if I'm comparing, say, teachers to students in the classroom, it doesn't make a whole lot of sense to say that we have 1/3 of a teacher to every 45 students. It just doesn't make sense at all. So how we did do this, the same thing we could have, like in number 4 when we had 24 to 8, yes, I could have divided those two, and yes, it did give me 3, which was the same thing as 3 over 1. But over here in the number 1 question, 1/3 to 45, yes, if we actually look at it as just division, 1/3 divided by 45, what that will do is it will give me a fraction as my answer when I divide those two, which in turn, again, a fraction is the same thing as a ratio. So I want to go ahead and do that. I divide the two. So going back to our division of fractions, 1/3 divided by 45, okay, they need to be in numerator-denominator form. So 1/3 is in that form. 45, I simply just put it over 1. In division, we keep change flip, so that leaves me with 1/3 times 1 over 45. When I go straight across multiplying these two, 1 times 1 is 1, 3 times 45 is 135. Meaning that my simplified ratio is the same thing as 1 to 135. That's how we simply switch fractions to ratios. And that can be done for all of the problems on there. Now, when you get to, say, what number is that? Number 3. Number 3 is a little bit more difficult because what we need to do there, like I just saw in number 1, I want to divide them for like fractions because I want my answer to be a fraction. The problem with number 3 is that we have a decimal as our first number. That's an issue when we have 0.8 to 2/5. So last class we went over how we change decimals to fractions so that therefore I could divide that fraction by another fraction. So let me show you what I mean. This is real brief, and this is actually going to help you with number 3. We're going to talk about this in the next class, so if this is just new information to you, don't stress about this. I'll walk you through on this one. This is the only place where you're going to see it on this quiz, so it doesn't really matter. To change a decimal to a fraction, you simply have to look at that decimal and turn it into a whole number. So how we turn decimals into fractions, we move that decimal as many times as we can to get it to the end. And that turns that decimal into the whole number 8 in this case. And that's actually going to be our numerator. Our numerator is going to be 8, but our denominator is going to be based on the number of times we had to move that decimal. Yes, we only moved it one time, but remember decimal movement is always moving by 10 because we're moving a whole place value. So if we ever have to move that decimal one time, my denominator is going to be 10. If we have to move it twice, then it would be like we've moved by 100. 3 times would be 1,000, 4 times would be 10,000, and so on. Think about it that you're moving place values, so that's why we have to keep moving by 10, or in other words, that's why we have to keep adding zeros. So I always tell people, however many times you move your decimal, that's how many zeros will be in your denominator. So our fraction there changes from 0.8, actually becomes 8/10, which then reduces to the fraction 4/5. So if 0.8 is the same thing as 4/5, then that means we can replace it up here in my ratio. 0.8, I'm going to use 4/5 instead. So let me go ahead and move this stuff around here so we can replace that. So 0.8 we said changed to 4/5, and then the second part of the ratio was 2/5. So again, if I simply just take these two fractions and divide the two fractions, once again my answer will be a fraction, which is the same thing as a ratio. So I'm going to take 4/5 and then divided by 2/5 is actually times 5/2 because we keep change flip. And then we can just multiply straight across. 4 times 5 is 20. Down at the bottom, 5 times 2 is 10. So my answer is always my ratio. So this is the same thing as 20 to 10. But we can always simplify. If 20 and 10 can both be divided by the same thing, then we want to do so. And they can in this case, so I simplify it down to 2 to 1. So that's the only case where you're going to have to change that decimal to a fraction. So we're not going to worry about it too much on this test. We're actually going to see it a whole lot more next class. So don't stress on that if that was tough for us. But let's go ahead and move on to the next section. The next section we then move on to to proportions. And we do proportions the whole rest of the test. So with proportions, in that case you're looking at two ratios set equal to each other. So like for instance on number 1 you have 90 to 15 equal to 4 to 2. Now proportions are read like analogies. So what this says here is 90 is to 15 as 4 is to 2. Now a proportion is only a proportion if the two ratios that are set equal to each other right now are actually equal fractions, or equal ratios. But that being said, ratios and fractions are actually the same thing, so this was an easy way to kind of test if a proportion is equal or not. So we talked about the shortcut method. A shortcut method for determining that, we can look at these two fractions and see, did I divide the numerator and the denominator by the same thing? Yes, that would totally work, but an easier way of doing that, since obviously down here at the bottom 15 divided by something would give me that too, but it's actually going to be a decimal. And we need to know if we did the same thing up here at the top. So instead of having to do that, there was an easier method for that, and that was a cross multiplication method, and we're actually going to use that quite often in this section, even next class. But what we do is we cross multiply both sides of our fraction here, of our proportion here, set our answers equal to each other, and that will tell us if this is equal to or not. Doesn't matter which side you multiply first. I'm going to go ahead and multiply 15 times 4. 15 times 4 is 60. So what I'm going to do is then set that answer equal to the other side. 90 times 2 gives us 180. Because those two answers are not equal to each other, then this is not a proportion. So you can just write on your test, you would just write unequal. But you can do that for every single one. Just rewrite your ratios as fractions, cross multiply both sides. If the two answers don't equal out, then it's not a proportion. We use a very similar method on the next section, but in this case, one of the components is missing on that. So what I mean by that, like on number 1, we have 180 is to x as 12 is to 24. That's how those proportions are read. Again, they're like analogies. So we're saying 180 is to something as 12 is to 24. So because it is an analogy, we can look at it. The ratio there on the right-hand side, 12 to 24, I know that 12 is half of 24. So my ratio on the other side is actually going to be very, very similar. So whatever we have there, 180 will actually be half of that number. So without having to figure that out, we can actually use that same cross multiplication method. So set them up as fractions again. Write it as 180 over x is equal to 12 over 24. In this case, it happens to be kind of easier to figure out because we know 12 is half of 24. But they won't always be that easy. So here's the shortcut method that we looked at last week. Technically what you're doing is you're doing that same cross multiplication method where you're multiplying both sides. But just to kind of show you real quickly, and then I'm going to show you a shortcut method to that. If I were to multiply 12 times x, I don't know what x is. So I would just write that as 12x. We're going to get into a brief section of pre-algebra, but then I'll show you that shortcut method in order to figure out that, how do we avoid the pre-algebra. So then what I do on the other side is I'm going to then multiply the 180 times the 24. Let me figure that out here. So 180 times 24, I'm going to multiply that. That gives us 4,320. So I would write that as 4,320. Okay, so now I'm left with this pre-algebra problem. When I multiply both sides, I have 12x is equal to 4,320, which means that 12 times something is equal to 4,320. So looking at pre-algebra real briefly, if you're not already familiar with how that pre-algebra works, what I want this problem to say is I want it to say that x is equal to something. So that tells me what I've solved for. Right now it says 12 times x is equal to something. So what I actually have to do is I have to get rid of that 12 that's on that x. And in pre-algebra, in order to get rid of anything, you always do the opposite of what's being done. So right now, because 12 is being multiplied by x, I'm going to go ahead and divide by 12 so that way I can get rid of that 12. That's what happens when you do the opposite. But remember what equals means. So that problem said that 12 times x was equal to 4,320. But on that left side, I divided by 12. To keep it equal, I've got to do the same thing on the right side. So then I'm left with 4,320 divided by 12, and that's actually going to give me on that left side 360. So x is equal to 360. Now, let me go back to that for a second, and let me show you there's a shortcut method in order to figure that out. Because every single time you're always going to be dividing by that number that's directly across from the x, as if I had cross-multiplied 12 times x. Shortcut method for that, multiply the other side first. Always multiply the opposite side of that x, so meaning I'm going to multiply where I have two numbers, 180 times 24 is 4,320. Then take that answer and divide by your last number, which in this case was 12. So when I do that, I automatically will get my answer for x every single time. So you can do the same thing on all of those. Just rewrite those as fractions, cross multiply the other side first, divide by the last number. Now on number two is kind of a trickier one because we've got decimals and fractions involved in that one. Don't freak out on that one. Anytime you see a fraction in a proportion, because I'm just solving for x, it doesn't matter what x is going to be. It could be a decimal, it can be a whole number, it could be a fraction if you really wanted it to be. But when you see those fractions in there, it'll be easier because we're just getting ready to cross multiply and divide. It would be easier to use those fractions written as ratios, written as decimals instead. So here's what I mean. So looking at number 2, I have 1/16 is to 1.6 as 1/8 is to x. So what I can do with that 1/16 and that 1/8, if I turn those both into decimals, it's going to make this problem a whole lot easier. And how we turn a fraction into a decimal is really, really simple. You simply take the numerator and divide it by the denominator. So in the first case, 1 divided by 16, if I were to do that in my calculator, it would give me 0.0625. And then I can use that to write over the second number of my ratio as written over 1.6. Don't worry that that fraction has 2 decimals as the numerator and the denominator. Not a big deal since we're just getting ready to cross multiply. So then I do the same thing over on the other side. If I were to take 1 divided by 8, to take that and turn it into a decimal, that's actually going to be 0.125. And then that's the number I will use to write over x. So now we have just nothing but decimals in this proportion. That's going to make it a whole lot simpler. So then I can just use my calculator to solve these types of problems. So what I mean by that, if I were to take, again, go opposite the side of the x, 1/6 times 0.125, that would give me, in my calculator, 0.2. And then I take that answer, just like our shortcut method that we saw before, and divide by our last number. In this case is 0.0625. Oops, I messed that up. And that gives me, 0.0625. Oh, whoops, 0.0625. That gives me 3.2. So my answer for that one would be 3.2. So don't let fractions freak you out when you see those in your proportions. We can have fractions and proportions, just make it a whole lot easier by turning it into a decimal. But use the same method for all of those in that section. Now it's the next 2 sections, the word problems and the conversions on the back, that we're going to have to set up proportions on our own. And how we set up proportions on our own is very, very simple. We just have to remember that proportions are read as analogies. So we're saying this is to this as this is to this. So they have that equal relationship on one side, on either side. So a prime example would be if I were to ask you, okay, if I have 3 feet, what is that in inches? Okay, with that being said, I can use proportions to figure out my answer there for how many inches by using what I know about feet and inches, and then set it up as a proportion and use my cross multiplication method. Here's what I mean. If I know that for every 1 foot there are 12 inches. And I'm writing that as a fraction for a reason. You're going to see that here in just a second. So 1 foot is the same thing as 12 inches. So if I set that up as a proportion and said, okay, well then 3 feet is then equal to how many inches? Or in other words, X amount of inches. You can see that what I've done is I've set that up as a proportion so that I have, now I can just cross multiply and divide. And some people would be able to look at that problem and say, oh, well, 1 foot is 12 inches, so therefore I have 3 times that amount, so I would just take 12 times 3. A lot of them will be that easy, and you can definitely just use your head to multiply that. This setup method is just for backup in case you need this, without having to do it in your head. There are a couple rules for setting up these proportions when we're setting them up on our own. Rule number 1 side of my proportion has to be my known. So this is what we know about, in this case, feet and inches. The other side of my proportion has to be my unknown. So this was the question being asked, and that's why that was our unknown. It's the same thing as the question, the 3 feet and the X amount of inches. And then what we do is we just set them up equal to each other. The only other rule we had for setting up proportions on our own, so rule number 2, was that our units had to match. You noticed on the known side I put feet on top, so therefore I had to put feet on top of the unknown side. Same thing with my inches down there at the bottom. I put inches on the bottom, so I put inches on the bottom of the unknown side. So again, therefore it was read as an analogy. I was saying 1 foot is to 12 inches, as 3 feet is to how many inches? So therefore I could figure that out, again, using our cross multiplication method. Our x was down there on the bottom right, so I multiplied 12 times 3, and that gave me 36, and then dividing it by that last number, which is 1, 36 divided by 1 is still 36. So that's how we'll solve all of them, making sure we've always followed those 2 rules. Unknown on one side, known on the other. Does not matter which one, because, you know, even if I were to put the unknown on the left and the known on the right, meaning if I were to flip those 2, I'd still get the same answer, as long as they're set equal to each other and my units match up. Totally fine. And then again, the 3 and the x had to be that one side because they're both part of the question. My 1 and my 12 had to be on the same side because they're both part of what I know about feet and inches. So let's try another one. I'm actually doing those ones from the back first. There's a reason why I'm doing those before the word problems. But looking at, say, number 1. Number 1 says that we have 12 quarts, and I'm just going to abbreviate, and I want to know what that is in gallons. Okay. Trick to this, when we have questions like this, you guys have a chart, so you guys can use the chart to figure out what the known is. The one I just did, the inches to feet, usually that's something we all are pretty familiar with. For those knowns that we are not familiar with, you have a chart. Do not worry about memorizing those knowns, because you guys will be able to use those on your tests and homework and everything else. So with that, the trick for this, here's how I always solve these. Because this is my unknown, I write it down first. It's right there in front of me. Before I go to look at the chart, there it is. So I go ahead and write 12 quarts over X amount of gallons. Therefore, when I go to put the known on the other side of my proportion, I know that I'm going to have to put quarts on top, because I had quarts on top of the known side, and because the unknown side, and because I have gallons on the bottom of my known side, I'll also have to put gallons. So what I'm looking for when I look in my chart, I'm looking for an equivalent for quarts and gallons. So I need something that either says so many quarts is equal to so many gallons, or so many gallons is equal to so many quarts. And if I look at that chart, there's quarts is to pints and to cups and to ounces and to all kinds of things. But there is a known on there for gallons and quarts, and it says that 1 gallon is equal to 4 quarts. So I'm going to use that as my known. But again, gallons has to be on the bottom, so my 1 gallon will be on the bottom. And quarts has to be on top, so my 4 quarts goes on top. So now I've got my proportion set up. Again, my 2 rules were followed. Here's my unknown on the left this time. Here's my known on the right. So known is equal to unknown. And then I've got my units matched up. So I just use my cross multiplication method that I used so often before. This time again, here's my x down here, so I need to cross multiply 1 times 12 first. That gives me 12. And then I take it and divide by my last number. 12 divided by 4 gives me 3. So therefore 12 quarts is to 3 gallons. The great thing about the word problems will tell you your known, so all you have to do is look in that question to figure out the known. So looking at, say, number 1 says you're asked to administer 75 milligrams of lidocaine. It is packaged 10 milligrams per 1 milliliter. How many milliliters do you administer? So looking at that, I need a known and an unknown. In that case, word problems are great because it gives us the known, and it tells me that it's packaged as 10 milligrams per 1 milliliter. So I write that as my known on one side of my proportion. The other side is the question being asked, which is asking me if I need to give 75 milligrams, how many milliliters do I need to administer? So you can see, again, once again, followed my same two rules. There's the known, there's the unknown, and my units match up. So I'm going to cross multiply the side opposite of my x and divide by my last number. So 75 divided by 10 gives me 7.5. All right, I hope that helped. See you in class.